What's up, guys? We're back again with another DSA grind. Just woke up from a post nap, post lunch nap. You know how hot that is. So yeah, today we'll be doing some lead code slash neat code again. First thing is I'll be reviewing some of the past questions that we did to ensure I'm still keeping things in my mind. The first was container with the most water question. So I'll just switch that up. Container. Yeah, I'll be a bit down. I just woke up from my sleep. As we continue, I'll get more and more energetic. But that this is the way I will be talking. Yeah. Okay, let's read through the question. You're given an integer array of heights of length n. There are n vertical lines drawn such that the two endpoints of ith lines are such that the two endpoints. Find two lines that together with the x-axis form a container such that the container contains the most water, and when they mean by most water, they mean the most area of water. Return the maximum amount of water a container can store, so you can't use slant. So how do you do this? Hmm. So the thing is we use a two-pointer approach. And why do we use a two-pointer approach? Let's understand why. So Excali draw is the code right over here. So the thing is we can have one left pointer over here and we can have one right pointer over here. And we see, so think about this, because this is randomly assorted, we don't know whether so one more thing, the bottleneck. Okay, so if we were to, let me just calm myself down. I think I'm going too fast. With these two line, the bottleneck in terms of height is the shorter line, right? So this, the container's height of this will be only 1 units, but the width is, we're not optimizing for width because we have to anyways check everything, so we can't really optimize for width as we go along. We have to only optimize for the length. Yahan pe the bottleneck is the smaller line. So in terms of height, it's pretty much the min of both height of I and height of j, which is you get them by indexing into the actual value. So we have to optimize for the height. So we don't know. So now if we, so the now the intuition is you move the pointer that is pointing to the smallest line. So we move the left pointer ahead. But why so? Because these lines are all randomly sorted. Let's say when it changes right, what could happen? It could get a higher line, which increases our height as well, because now the bottleneck will become this, or there might be, let's let's take it. Okay, if the next line in respect to the line it's currently in with, it may be higher, so it improves our height factor because now this is the bottleneck. It could be the very same height, which is again it remains constant, or it could be smaller, it still increases, or it could be no, if this comes, it could be the same height but is constant. It could be bigger than this, also constant, or it could decrease, right? So what's the right way? I'm so confused right now. What am I doing? Why do we move the pointer that is pointing to the small height container? Because agar if it faces a huge height container, then our height parameter will increase. If it's of the same container, then it is constant, and if it faces even a smaller container, then though our height goes down again. Okay, that is the things that's going to happen. If we look at the right pointer, if we then change the pointer that is pointing to the highest height, first of all that sounds wrong. If it Now if it goes to a higher count, it still remains constant, right? Because now this is the bottleneck again. If it goes to the constant, it still remains constant. So if it's bigger, constant. Even if it's small, now that depends. It could, if it's small, it could again be constant, or it could be, in a sense, it could be even less. So as you can see, the issues with that is if we move the less pointer, our probabilistic chance is much better, because if we move the right pointer, it's going to be constant, constant or small. But over here we have a sliver hook and it might also lead to a bigger chance. So we move the left pointer. We first of all record this. We record this height, like we record this area. So we just to make sure we are recording this in some variable. Then we go to this and we calculate. Okay, wow. Again, we move this. This comes over here, right? We calculate that and we move this. Now this is an interesting edge case. Now both are 8. And in the NeetCode video, he said that you can. It doesn't really matter which pointer you move left or which pointer you move, it will fix out. But I just want to say what I did in the actual question is I moved it left and right. But if our aim is to optimize for length, then what we could do is check one step ahead. Okay, we can check. Okay, so because this one is 6, and if I can see this one is 4, we can see that 6 is greater. And so if we were to move the right pointer, we'll be exposing it to, we'll be exposing 8 to 4, which is not bad. But if we move this, we'll be exposing 6 to 8. That is much better, because now the bottleneck was, before it was 4 the height, but now it's going to be 6. That's much better in that sense, so we can do that optimization. And yeah, so this will come and we'll have it one left. So let's try to code this up. Actually, this is my old code, and just so I don't cry if that goes away, I do have the old code in container with most water. So if this opens up, I have the old code, so I won't really worry about it. Let me just delete the old code and let's try to form this idea on ourselves. So we do L is equal to length of height. We'll say max area is right now we'll assume it's 0. uh, Actually much better is something like L pointer is, so what is the length over here? The length is 2. Okay, yeah, so that works for us. And we can go, I think that's much better. L is equal to len of height, right pointer. Actually, let's do this in both same line. So L right 0 is L minus 1. This works. Just format my code real quick. All shift, yeah, all shift F, all shift F. I clicked all shift F. Didn't work. Yeah, okay, so this is just gonna set up when we can have max area is equal to 0. Now, while left pointer is less than L pointer, so that's the common standard, and we don't want them to cross, because then that would be checking cases. Um, yeah, if it crosses, then that's an issue, right? Because if it crosses, like, let's say left right pointer, we're checking the same thing again. Let's do something very simple. We will do height, which is equal to min of, okay, I call it H. The names could be better, but I call it the min because that's going to be the min of that. So we'll say height LP, height RP. I'm going to say breadth. Well, the breadth is going to be RP minus LP, right? Indexes. If you take the base of 1, 1 is 0, 1. So what is the length between the 1? 1 minus 0, 1. That makes sense. And we'll say max area is equal to max of max area, or L, or H into B, right? Now, if height LP is less than height RP, uh, LF, let's actually copy this statement because that works in our favor. LF, okay. So, agar right one is bigger, we will do LP plus 1, and we will do RP minus 1 over here because LP is greater. So we'll do, and the edge case over here is when height LP is equal to height RP. And over here I would like to do an optimization, but before that let me just return max area. And the optimization doesn't really matter for now, but let me just see if this test passes. You can also do one. Let me see if this test passes, because I want to see if this is the right code. I know this is the right code because I still recall the right code I wrote like few days ago, so it's not that it's out of my memory. Let's see. Judging. I feel judged. Okay, time limit exceeded. Great. Uh oh, my bad. My bad. This is um what did I do wrong? Actually, what? Okay, let me see what I did wrong. So L is the length of the height, LP is set to 0 at the moment, and RP is set to L minus 1. Max area is 0. So while LP is less than RP, the height is actually the minimum of heights of LP and RP. That makes sense. And the breadth is RP minus LP. Max area is supposed to be max area into N into P. Now, if height LP is less than height RP, we will do LP plus equal 1. And if height LP is greater, we will do RP minus 1. Uh, Return max area. I don't think anything is wrong with this. What? Interesting. But it's the same code. Okay. Length is equal to min of height LP. Okay. Width is RP minus LP. Yes, sir. RP minus LP. If max area. Okay. This is just doing what I just said it to. If LP plus equal. Yeah, LP plus. Um, am I doing something wrong? I can't think of. I'm time limit exceeded. This I must be doing something wrong over here. Then L is equal to length. RP LP 0 L. It's some dumb reason why it's not working. Max area is 0. H is equal. I mean, I'm just using dumb variables. To be honest, this yeah. So this thing over here could be pretty much written as uh, max area is equal to max of max area length into width, right? And this would still work. And okay, this is just dumb. Uh, yeah, I know what I was doing. My bad. That was dumb. Okay, after this works, I'll do a better solution to this. And the solution now I'm gonna optimize this. So, okay, what's gonna happen is I'm gonna save height. I'm gonna check LP plus 1, right? What we said is we're comparing this with this. If height LP plus 1 is greater than height RP minus 1, I'm correct, right? Because LP का यहाँ पे होगा, R का because it's over here minus 1 this. If that is the case, because it's very rare कि वो भी same होगा, unless I mean that would be very dangerous if we have 8 and 8. But if it's greater, okay, let's just say if it's greater than or equal to, let's just be more okay. If it's greater than or equal to this, we will pretty much do LP plus 1, and the opposite could be that is there, so we can do CWRP minus 1. Let's see if this micro optimization, I don't know if this is optimization to begin with, just I just want to see pass the test case and then we might go ahead. What is the issue? My bad. Sorry. Okay, so it passed the test case. Okay, it passed. Runtime is, let's just say I'm in the median. Who are these people? Huh? Who are these? ये क्या है भाई? Huh? ये क्या है? Why is bro printing binary to the screen? Is this some kind of cheat code or something? You don't tell me he's executing just like raw hexadecimal code. What? Okay. Left is this. Okay. Okay, so he condenses that in a single line. So max area is equal to R minus left into min of, yeah, makes sense. If height left, if height left is that, then this, oh, he just condenses it. So whatever that is. Okay, that's even much more readable. Um, Considers the width. Um, Okay, who's this guy's code? Okay, I don't know, that code is so cluttered. Anyhow, so that was container with most water solved again, but I at least I understood the logic over here. And I think the understanding was key. If you change this right pointer, regardless of whatever the outcome is, greater, constant, or even letter, you will be going and ditching over here. It's much more beneficial to that. Cool. Done. Let's see if I could get that tick. Okay. Then we have the longest consecutive series, which is a very interesting question. I'm like one of those questions that just was like, "Ooh, that's interesting." Um, Longest consecutive series. Um, okay, so the thing is, you're given an unsorted array of integers nums. Return the length of the longest consecutive element sequence. And um, yeah, so I won't look at this. Let's close that. Okay. A consecutive sequence is a sequence of elements in which each element is exactly one greater than the previous element. So if you have a over here, you will have a plus 1 over here, then you will have a plus 2 over here, because if you check them consecutively, a plus 2 minus a plus 1, the only difference that they have is exactly 1, right? The elements do not have to be consecutive in the original array. You must write the algorithm runs in O of n time, which is a very interesting gambit. Let's take this example. Okay, so we have 2, 24, 10, 3, 4, 5. And so the way that NeetCode explains this was very genius. What he said was, imagine a number line, and imagine putting those numbers on the number line. So you would have something like true over here, you would have 3 over here, you would have 4 over here. Also, for the duplicate case, I'm assuming you're making this into a set. So let's remove this. I won't try not to see. I'm assuming you will do num set is equal to set of num. So this what it does, it just removes the duplicates for us, so we don't have to worry about the duplicate case. And this runs in, you could think of this running in O of n time complexity, even though there's more of O of n's, bunch of O of n's over here, but yeah, sure. So we have 4, so we have 2 done, 3 done, 4 done, and 5 done. And then this is one group you can think of. And then you will have 10, and then you will have 20, right? Now, how do you know if a given number out of them is a start of a sequence? That's a very good question. How do you know? How will you know if the number you're looking at is the start of the sequence? Because if you notice, how do we know that 2 is start of a sequence? Because there is no number before it. So this is a start of a sequence, right? There is no number before this. It's start of a sequence. Look at 3. Why don't we say 3 is a start of a sequence? Because 3 ke pehle there's a number that exists, right? 20 se pehle there's no number existing. That means 20 is the start of a sequence. Now we don't care how long that sequence is, whether that sequence only contains 20, but it is a start of a sequence. And this is the very first logic that we can get hang of, right? So we first see, okay, this is the start of a sequence. Great. And the question says we need to return the longest sequence possible. So in this case, longest sequence will be 1, 2, 3, 4. Right? There will be the length of 4. And so then this we know the length sequence, and then we can go, okay, there's a number to the right, so that has to be, okay, so number 2 of its right and number 2 another of its right. That means this is a sequence of length 4. And we can say this is, so we could have a variable that says length, which is 0 at the moment, right? So we can say for num in nums set. Now while uh, num minus 1 not in num set, what this does is exactly what I was explaining over here is, if we, let's go on 2, if 1 exists, we don't even start this loop because it's not the start of a sequence, right? Why would we do that? That would be dumb, right? Because 2 minus 1 1 does not exist in the set, meaning that 2 is start of a sequence. Now we don't care how long that sequence is, but this is a start of a sequence. Then we can say, oh well, if this start of a sequence, then length is equal to 0. Now while length is equal to 1, because we have gotten one element of a sequence. Now while num plus l in num set. Now what does this mean? It means, okay, now we have gotten one element of the sequence. Now using that one element variable, we can say now 2 plus 1 is equal to 3. Is that in our sequence? Is that in our array? And that is O of n search. That won't be longer than O of n. If that is the case, then we'll do O of n plus equal to 1, and this will keep incrementing our length. So okay, it's 3 here, great. So now we have two elements. Now 2 plus 2, 4 is 4 here, great. Now we have 5 elements, right? I'm sorry. Uh, okay, num plus 1, 2 plus 1, 3. We have 3, great. Now we have two elements in this. Now it becomes 2. 2 plus 2, 4. We have 4 elements. Great. Now we want to check 3. 2 plus, like, it keeps checking like that. And then what we will do is we'll do max, we will do length is equal to max of length L, right? And you can see your code is set to local. Okay. And so what this does is just again checks local kya, and I want to do this actually before this, because you see this loop, um, okay, while this is in that, we want to do length is equal to 1, and we'll check, um, I mean it doesn't really matter where I place this, does it though? Let me just check one more thing, which is return length. Okay, let me think about this. These are things that are interesting. So we calculate, so for 2 we do this, do this, do that, and we come down to this loop. That shouldn't really matter. This shouldn't really matter. I mean, this has no effect if it's inside over here, to be very honest. If this something goes wrong, then I'll be very sad. Time limit exceeded. Why so? While num plus L is in the set, um, okay. While num minus 1 not in num set. So let's just take 10's case. क्या 101 है, क्या 99 है, नहीं है, right? So we do L is equal to 1. So while num plus 1 is in set 101 नहीं है, this does not even run. um, but this doesn't even run. Okay, and then comes over here and checks this again. Hmm. This is not a good way of doing this, because I'm just telling them to do, okay, if num minus 1 not in num set, we will do something with it. Plus L in nums set, right? So if we just check first, if number not in the num set, let me do L is equal to 1 while n plus L in num set. We will do L, this will be our breaking condition, and then finally we will say length is equal to max of length L, right? This is much better, because we were just like blindly just looping through it, which is dumb. Yeah, this is why you should revise all the questions. It teaches you to think about the algorithms again. So yeah, this is, if we don't blindly do that, we ask ki, okay, kya ye hai bhi, right? If not in num set, then if it's not there, then we don't even bother checking it again. um right, L is equal to 1, and that, let's look at the code over here. If num in num set, yeah, so something like that. The previous was so dumb, right? And return length. Yeah, great. Yeah, so that was easy. Got confused there, but where's the text tool? Okay, done. Okay, now we have to sum 2, which NeetCode doesn't has it, which is interesting. Yeah, to sum 2 input array is sorted. So now let's say, okay, let's just copy this. Okay, so how do we solve this question? Again, this is a two-pointer approach. We are told that our input array is sorted and there's exactly one pair of elements that will give us the target, which is 9, and we have to just return their indices, which is 1, 2, as you can see, 2 plus 7. Those, and you can see, given one index array of one index for God knows what reason, I had to L plus 1 there. Let these two return the indices of the two numbers. The tests are generated such that there's exactly one solution. You may not use the same elements twice, and you can only use only constant extra space. Yeah, so how do we do this? And the solution is quite fascinating. We first keep a left pointer over here, and we keep a right pointer over here, and we compute the sum. Right, so if we compute the sum, we'll do 15 plus 2, which is 17. Why is my screen? Is that a screen flash or is that? Do you guys see this? Interesting. Okay. So we do 15 plus 2, it's 17. Now 17 is greater than our target value. And so the only way we can decrease this sum's addition value is by decrementing our right pointer, because we cannot decrement our left pointer. It's already at the minimum most element, and if we increment it, we'll be sure to have a number that is greater. So if 15 plus 2 is giving us some value x, then 15 plus whatever comes next to 2 in some of sorted will obviously be greater than x, and we don't want that because x is far greater than 9. X is greater than 9, and x is, yeah, okay. So we do right, and we do 2 plus 11 and we get 12. uh, my maths is, we get 13, right? 13 is again greater than 9, so we can't really do that. We have to only decrement our right pointer, and then we'll do 2 plus 7, which is equal to 9. Now we can't have the left and right pointer collide, that is be on the same element, because that doesn't make sense. The same element can't be it, and they said there'll be exactly one solution. That means there'll be exactly a pair. Let's choose another example. I mean, that is a simple example. But yeah, that is the case here, because we have to keep closing this. And let me just uh, yeah, yank this because I don't want to get rid of this solution. It took me long. Okay, so we will let's look at the length. What are we working with the length over here? Okay, so our length starts with 2 to 3 into. Okay, so we do a left pointer, we do a right pointer. This is 0. This will be length of numbers minus 1. Now we'll do while L pointer is not colliding with the left pointer. Can you guys show the visual line for God's sakes? Anyhow, yeah. So we will say, well, we'll have a target value. Um, what? So the idea is if numbers LP. Actually, let's just have a sum. So S is equal to. I'm still remembering the LP. Right. If S is greater than our target value, that means it's greater. So we have to decrement our left right pointer. And if S is less than our target value, right? The only way, yeah, if S is less than our target value, that means we have to increase it. Now, if we decrement the right pointer, we are bound to decrease our addition. The only way to increase it is by incrementing the left pointer. So we'll do LP plus 1, else return LP plus 1, RP plus 1, and we are bound to reach this because that's how it works. And if I run this code, yeah, so that passes the test case, and let's see if it passes the assignment. It does work. That is great. One more thing, if you see over here, not many people have solved this, so the gradient is very like visible. Uh, yeah, I use this, which is, I guess it's something much you can improve on. But yeah, that is pretty much 2.2 for y'all, and that is done as well. That was easier said than, yeah, 2.2 dusted. The question that I really want to solve is the product of array except itself, which has been driving me, let's just say, crazy, because I saw the solution for it and I was like, wow, that problem deserves something else. Um, I solved this in a dumb manner. First of all, this is a very dumb solution. I wanted to solve this the way NeetCode said, but I just was not able to understand what he was trying to say. My mind just stopped. So, anyways, I do understand what's happening over here. Um, so we have an array. Let's try to clip this of B of A, B, C. Let's keep this very small. And we want, so this is our array, and we want the output array. Let me just drink some water. We have array ABC, and we want the output. So, given an integer array of nums, return an array answer such that answer I is equal to the product of all elements of nums except nums I. The product of any prefix or suffix is of nums. Okay, this is for people using C and all, so best of luck. You must write an algorithm runs an O of n and without using division operation. Uh, Whoever did this, I hope when you turn your pillow, it's not cold. And I mean, I saw a comment where someone said, well, I could just set something like power x to minus 1, which is clever. I mean, it depends on this. It's technically you're doing something like this. Um, no, I mean, that's like harm 1 by x. Yeah. Um, yeah, good. So what we want the output of, so this is 0 and this is 1 and this is 2. We want the output for this to be B into C, for B to be A into C, and for C to be A into B. Okay, and our idea is we want to do this in O of n time, mind you, O of n time, and in constant space complexity. Now, the problem assumes that the output array is not considered. If you see, I think in the problem itself they say, can you solve this in O of n? The output array does not count, right? So the first thing I'm going to do, because I don't want to see all the, I'll delete this. I will, this was my actual solution, my O of n square solution, which I would say is much, I don't do that. This solution was something LeetCode told us that is O of n space complexity, so technically not O of 1. So why is this thing like happening like this? Okay, product of array except itself. Even if I see the answer, I won't be able to solve it. Okay, can't even copy. Why can't I copy? Did I copy or not? I didn't copy. Why is this? Why is this torment happening? Did I copy or not? Okay, now I copied. I paste. Okay, I can't paste for some reason. It must be in my sticky note. So let's see. This is over here. Yeah, let's see if this runs. This used two arrays, a prefix array and a postfix array, and but now the thing is key you do this, and the thing is about after solving this, I didn't understand it, so that was weird. Okay, so we want B into C, A into C, and A into B, and you see why B into C is every element will have a prefix elements, the elements that come before it, and postfix elements, the elements that come after it. So if you want to find the product of everything except B, we find all the prefix elements, we find all the postfix elements, and we just multiply them together. Now, let's say our output array at the moment contains nothing, right? We'll assume they contain 1 because we have to input something. And we do a pass through one time. So when we do a pass through, we'll put, so over here A का तो कुछ है नहीं इधर, तो we'll just, prefix of A is nothing. Prefix of B will be pretty much A into B, right? And then finally when we come to C, it will be A into B into C, right? So A aa gaya, we come to B, we do B into whatever the previous thing, now we get all the previous element, and now we get all the last element. Now if we come and walk through over here, walk through over here, we'll have C. The thing is, I want to say because now I want to do the prefix. Normally you would do the prefix, which would be like C, like B into C, and you'll be like A into B into C, and then we would be like, oh well, so we go to find about A. So A का prefix यहाँ पे मिलेगा हम लोग को. A का prefix कुछ है ही नहीं. A का postfix हम लोग को यहाँ पे मिलेगा, यहाँ पे apparently. B का prefix ये है, and oh yeah, B का prefix ये है, ये okay. Now I understand what happened. So okay, so it contains, so if we contain for B, it contains all that, and upon C का सबसे पहले will A into that, and but C का खुद रहेगा A into B into C. This is doing this so if there's any element over here, makes sense. But now the question is, this is our output array, and now we are coming backwards, right? Now we're coming backwards. Now we get exposed to C. I'm so blinded over here right now. I don't know what to do. Might as well just accept defeat and watch the video again and try to understand what's happening. Okay, let me understand this again with using prefix in that. So we have A, we have B, and we have C. We have prefix, postfix. So A का prefix 1 है, right? A का prefix 1 है. B का prefix, तो we have to store that somewhere, so we can't just say नहीं है. We have to say A है. Let's assume A है अभी के लिए, because A का prefix 1 होगा. The reason why we are storing this A over here is because this helps us not going back and forth. B का prefix B का prefix A है, but we need to store B for further reasoning, so we have B there. C के prefix elements के ये हो गया A into B into C. Now postfix, इसका postfix कुछ नहीं है, 1 है, but because we are good boys, we'll put C over here. B का postfix C है, A का postfix ये है, so हम लोग A को भी include करेंगे. Now I want to find out what will be the product of all the array elements without A. So I'll do prefix into postfix. Now मुझे पता है A का prefix 1 है. 1 into postfix मतलब इससे पहले वाला एलिमेंट और इससे पहले वाला एलिमेंट में मुझे B into C आ जाएगा. Great. B का prefix A है, B का postfix C है, तो A into C. C का prefix हम लोग को पता है B into prefix ये A into B होगा, and postfix कुछ नहीं है because वो last element है. So ऐसे हम लोग का आ गया आंसर. Now so I think I understand this. हम लोग A C यहाँ इसलिए लिख रहे हैं even though 1 है, is because, and I think Neet could explain this but I was not paying attention, because why pay attention? We do this because we don't have to do back and forth, but we'll assume it's 1 for them. Right. So how do I figure this out now in one pass? If I do one pass over here, we essentially what we create is we go look at A, like okay A का prefix कुछ नहीं but A का prefix A है. Great. B का prefix क्या होगा? A होगा, but we have to store B का value, A into B, पिछले element A into B into C. Now भाई यहाँ तो मुझे चाहिए B into C, यहाँ पे चाहिए A into C, और यहाँ पे चाहिए मुझे B into A. अब मुझे मिल रहा नहीं है. I have to watch the video. I guess that's the only simple reason. Top comment was so good. The local fast. Okay, so what's happening over here is one ka prefix is nothing, but we have to store one for let's just say historical reasons, and then two ka prefix is one. So we do one into two over here, right? इसका prefix है two into six, so two into three. Four का prefix ये सब है, so four into six. Now four का postfix, right? Four का postfix कुछ नहीं है, it's one. We have to put one, but we do four because we are less like that. Four into one. नाउ थ्री का पोस्ट फिक्स क्या है? थ्री का पोस्ट फिक्स फोर है. फोर इंटू थ्री 12. देन टू का पोस्ट फिक्स क्या है? वट एवर यहाँ तक हुआ है 12 इंटू टू. एंड ये क्या है? ओके, सो दैट मेक सेंस. ठीक है. Okay, that makes sense. um so if we have the input array over here, the prefix of this is well 1, right? The prefix of this is well a, and the prefix of c is well a into b, right? And now we do the suffix. We come from here. We know कि इसका postfix तो कुछ है ही नहीं, so this will be into 1. um, b का postfix is c, a का postfix is b into c. a comma b comma c. a का prefix is nothing but 1, b का prefix is a, c का prefix is a into b. That is on this pass. Okay. On in this pass, c का suffix is 1, b का suffix is c, and a का suffix is b into c. How do I do this? um Back at it, a b c. So prefix of a is 1, prefix of b is a, prefix of c is a into b, postfix of c is 1, postfix of b is c, postfix of a is b c, and so we get that. But how do we code this? That's the real question. Okay, let's do one pass through. One pass through, maybe go through a. If we go through the first element that we can know by the pointer pointing to the index of 0, then we can put 1 over here, and we can essentially just put it to the next element. We come to b, and we know b will be the next elements, essentially. So we will essentially do this next element, and we will also use this element to get over here, and then we won't even do anything with c because c will not really contribute anything. So a way to think about this is, again, let me just check. Here the same is the solution. Okay, there's different solution. Okay, nums except is equal to length of nums. Yeah, nums except, or I'll just say out. Okay, nums except one length of nums. Okay, and we'll have a, b, c. So for first pass for calculating prefix, we'll say um, for I in range of, again, let's just do L is equal to length of nums, and we will do this as L. Okay, so this is our first. So L length of nums except this first passed for calculating prefix, right? What is the max minimum? Okay, so if I is equal to 0, that means this is the first value. We will to be honest, we don't really care. We will say nums except is equal to nums I, right? Because this will a, b, c, 1 1 1, right? A into b, and this will be um I mean, to be honest, this could be something like um nums into nums except I, because that makes sense, because nums I is over here I, and if we do 1 1 1, this is 1. So a 0 1 2, 0 वाले पास में 0 plus 1 1 वाले में we'll have this into जो इधर वाला है, that is a, right? Then we come to b. So b is 1. As b is 1, we'll calculate 2 wala, and the way the 2 wala will be calculated is we'll do b into a. Okay, so that makes sense. We'll have b into a over there, and well, c तक तो जाने की ज़रूरत नहीं है हम लोग को. To be honest, c तक जाने की ज़रूरत नहीं है, because this is 3, right? 2 है तो 0 1, तो 0 आया तो इसने अपना भी काम किया 1 का, 1 आया अपना भी, और 2 का काम कर दिया इन लोगों ने. That will be it, right? So 0, so this does this, 1 takes that, updates that, 2 tak to we don't need to do anything, right? Then we do second pass for calculating postfix for I in range, and this has to start ulta. So we'll have a, b, c, 0 1 2, and abhi tak we have 1. We'll have a, right, and we have a into b, and so we don't want to start from 2 because nothing, I mean, 2 we can start from 2 in a sense, and I think the best way to do this would be to, I guess, um, I is equal to L, while I is greater than or equal to 0. We will, this is just trying to fix out some structure over here. I is equal to that, actually 2 हो गया, and so this is 2 pretty much. And so what we want to do when we do 2 is we want to put it over here, right? um, yeah, so we'll do A into C and we'll come to B. सॉरी, हम लोग ने प्रीफिक्स में क्या किया, हम लोग वो किए and that is A into B. now हम लोग C में स्टार्ट कर रहे हैं 0 1 2, right? Second pass for calculating postfix 2. um so when we add 2, we don't really need to do anything, we just have to put this over here, right? Then we come over here and we essentially over here we want B into C, to be honest. And how do we do that? ऐसे ऐसे किया था. how do I, मैं prefix calculate कर दिया, postfix कैसे करूँ? postfix इसका क्या है? इसका postfix 1 है, तो यहाँ we'll have into 1. इसका postfix C है. okay, yeah, I'm lost. So I did the prefix calculation, which was easy. We did nums 1 2 का भी हो जाएगा. okay, yeah, that makes sense. How do I do that? This was much easier. Does this work though? Yeah, this does work. So we have C over here. It's so cluttered. Anyhow, okay. 0 1 2 0 1 2. Now C का postfix 1 है. Let's C का postfix is 1. Well, C just has to go over here. So it pretty much multiplies its postfix and then multiplies over here. Then we go to B. B का postfix C है. Again, how do we do this? Okay, guys, I'm gonna wrap this up. I don't think I can come up with this solution myself at the moment. Does that mean I'm giving up? Hell no. It's just like I'm gonna make another video where I'm gonna solve this again because, to be honest, this was such a like a brain fuck of a question. And I think I have to upload another video of it using Golang Academy. So I guess that will be it. Thank you for tuning in from the late night session. Bye bye.